Within Topic 6, Solving Systems of Linear Equations and Inequalities, this is Skill 34. Solve a system of equations using elimination. So far, we have learned that you can solve a system of equations using graphing, the solution being the point where the two lines intersect. We also have looked at another method of solving systems of equations, and that was using substitution. And this works because it converts one of the equations into a one-variable equation instead of a two-variable equation. There is another method of solving systems. It's called elimination, which is Skill 34 topic. And it's so named because in using this method, your goal is to eliminate one of the variables. And here's an example that we're going to look at. And the steps are written for us, Step 1, Step 2, and Step 3. The first step is to add the similar terms of the two equations. And it really helps if they are written so that the terms line up. In other words, the x's are together and the y's are together. First thing I'm going to do is make this minus y a plus a negative. So I'm going to just go ahead and add down. So 5x plus 3x is 8x. A negative y and a positive y is 0y, and that's what we mean by eliminate one of the variables. 12 plus 4 is 16. So now I have to just go ahead and solve for x by dividing by 8. So I get x equals 2. And I am half done because I have one variable, I need the other. And to get the other variable, I do Step 3. I substitute the value that we found for x, which is the 2, into one of the equations and find y. You can use either equation. I'm going to use the bottom equation because the y in that one is positive, and it makes my solving a little bit easier. So 3x plus y equals 4, so 3 times 2, because that was my x, and then plus y equals 4. So finish solving this equation for y. Get y equals negative 2. Just like in graphing, we're going to write our answers in an ordered pair, alphabetically, x, y. So my answer to this problem is 2, negative 2. Now, just adding the terms will not always guarantee that one of the variables will disappear. Can you think of circumstances that would make this happen? If one of the variables has the same coefficient and the same sign in both equations, what would we have to do to change one of the equations so that the variables would be eliminated when you add them together? Let's take a look. So under example 1a, if we look at those, can we add straight down and will one of the variables be eliminated? And the answer is yes. So I'm going to change that minus y to plus a negative again. So we get 2x equals 18. And I'm going to go ahead and solve for x by dividing by 2. So x equals 9. And once again, I'm going to put that value back up in either equation. And this time, I'm going to choose the top equation because that equation of y is positive. So x, which is 9, plus y equals 14. So I'm going to add a negative 9 to both sides. And I get y equals 5. And once again, I need to go ahead and put those in an ordered pair, alphabetically, x, y. And that is my solution. Now, something we didn't talk about in the other one is I need to check to make sure it works in both. Well, it works in the top equation, 9 plus 5 is 14, and it does work in the bottom equation. 9 minus 5 does give me 4, so I have checked it in both equations, and it works. Now, in B, if I were to add straight down, I would get 6r plus 3s, and I didn't eliminate a variable. So this is what we talked about we might have to do some work before we add down. And it has the same coefficient and the same sign. So what I'm going to do is I am going to go ahead and multiply this equation by -1. And when I do that, my top equation stays the same, and I get negative 3r plus a negative s equals a negative 7. Now I can add down, and I eliminate my r's, so I get s equals negative 5. So once again, using either equation, I substitute that back in and find out what r is. And I'm going to use the bottom equation just because I can do less work that way. So I have 3r plus a negative 5 equals 7. So I'm going to add a 5 to both sides. And I get 3r equals 12. And then divide both sides by 3. And I get r equals 4. And once again, they need to be back in an ordered pair alphabetically. So alphabetically, it would be rs or 4, negative 5. And I should check that in both original equations. And I'm just going to check it in the top because I use the bottom equation to solve. So 3 times 4 is 12. A negative 5 times 2 is negative 10. And that does equal 2. So it does check. However, there are many cases where neither of the variables in the system have the same coefficient at all. And in these cases, you may have to multiply all the terms in one or both of the equations by some number to make that happen. So example 2a, if I look at those, I can't just add straight down. I wouldn't eliminate a variable. So I can choose to multiply either equation by a number or both equations. But it's a little bit easier that since this 5 is negative and that 10y is positive, then I'm going to work with those. So first of all, I'm going to change this to plus a negative. And I'm going to choose to multiply the top equation by 2 so I get a negative 10y. 8x plus a negative 10y equals 46, and 3x plus 10y equals 31. Now if I add straight down, I get 11x equals 77. So I'm going to divide both sides by 11, and I get x equals 7. Then you can use either equation again to find out y. And I'm going to go ahead and use the bottom equation once again because it is positive. So 3 times 7 plus 10y equals 31. So 21 plus 10y equals 31. Got to add a negative 21 to both sides. And I get 10y equals 10. So y equals 1. Ordered pair, xy. Once again, I do need to check. So if I check the top one, 28 plus a negative 5 does equal 23. and that's my check. Example B. Once again, if I add straight down, I don't get a variable to drop out. If I look carefully, I can drop out the y if I multiply the top equation by a negative 2. So if I do that, I get negative 12x plus a negative 2y equals a negative 12. I get 3x plus 2y equals 9. And I'm getting a lot of negative numbers, so maybe that wasn't my wisest choice, but it doesn't matter. It will still work. So if I add straight down, I get negative 9x equals negative 3. And you immediately think you've done something wrong because you can tell that's not going to be an integer. But as we've learned before, that's okay. Finish it out. I'm going to divide both sides by negative 9. So x equals positive 1/3. Now, again, I can choose either equation. I'm going to choose the top equation. So 6 times 1/3 plus y equals 6. So 2 plus y equals 6. So I'm going to add a negative 2 to both sides. And I get a y equals 4. So once again, alphabetically, x, y. And I should check that in the other equation. 3 times a third is 1, plus 8 is 9. It does check. I'm going to stop this recording at this example. If you want to see further examples, check the Part 2 recording.